Hello. For this problem, the commercial for New Meat Man Barbecue claims that it takes 19 minutes for assembly. A consumer advocate thinks that the assembly time is different. The excuse me. The advocate surveyed 11 randomly selected people who purchased the meat barbecue and found that their average time was 17 minutes. The standard deviation for the survey was 2.8 minutes. What can be concluded at 0.10 level of significance? So there's only 11 randomly selected people, and the standard deviation is from the sample, not the population. If it's not from the population, then it has to be a t-test. So the main thing you're looking for, whether it's T or Z, is the standard deviation. If it comes from the sample, it's T. If it comes from the population, it's Z. The null hypothesis, H sub 0, is always equal to. So this would be equal to. This is going to give you two choices, mu or P. Because this is average time, this is mean. And the value, assembly time, was 19 minutes. So that's what we're testing. Now they feel it's different than 19, which means it could be greater or less. So it will be not equal to. That is a not equal to sign. It looks kind of small, but there we go. And this stays the same, mu and 19. If this would have said greater than, then it'd be a greater than. If it said less than, it'd be less than. But different or not equal to is a not equal. Test statistic. So to find these values, you want to use your Excel spreadsheet, the one in Chapter 9 that says hypothesis testing for mean, because there's one with proportion, there's one with mean. So for this one, we want this. Let's move this down a little. I don't know why it got big. Okay. N is our sample size, which was, I think it was 11. There it is, 11. The population mean, that comes from your hypothesis. It was 19. The sample mean, I think, was 17, yeah. The sample found a mean of 17. Mean and average are the same thing. Standard deviation, 2.8. And alpha, 0.1. So our test statistic is a negative 2.36902. Now, we were testing not equal to, which means it's two-tailed. Greater is right-tailed, less than is left-tailed. But this would be two-tailed because it's not equal to, so this would be our p-value. So test statistic, it's T because it's a t-test, and negative 2.369. P-value, I'll bring the Excel sheet up in a second. P-value is less than or equal to. Oh, yeah, we'll bring it up first. It was weird, the wording. Okay, so our test statistic right here our p-value, it's this one on the bottom because it was two-tailed, not equal to. Now, if the p-value is less than alpha, you reject. Greater than, you fail to reject. 0.03 is less than 0.1. So that's why they have the less than. Because the p-value, 0.039, is less than 0.1. And if the p-value is less than, you reject. And so this one should say reject. Now this one's just on wording, and you want to be careful. The data suggests the population mean is significantly different from 19. Because we rejected, there's statistically significant evidence to conclude that the population mean amount of time of assembly is different from 19. Now we can't say less than or greater than because we only tested that it was different. But it is different because we rejected.